Hey everyone, here we are, doing a little bit of streaming. Now, I am going to do exam paper stuff on here. It'll be fun, probably. Anyway, first thing I should probably do is tell you guys about it. Doing chemistry exam revision now. Streaming on Twitch. I will post the video on YouTube later. There we go. I shall post that along with the link. Hopefully you can find it. Anyway, here we are. We are going to today do a little bit of exam revision on the internet. I thought, yeah, let's do this. So I've got my whiteboard software. I've got my little clicky whiteboard thingy-majig, which allows me to write on this. Probably. And I have got, hang on, let's unselect that. There we go, I can now write it. Now, we can now go through this and just do the questions like we normally would in a normal situation. So, here we go, let's just get started. So this is Group 1 and 7. Okay, so I've skipped Group 0 because the Group 7 questions were quite long. It seems like a lot of pages, but actually they're quite short questions, so it shouldn't take very long. We'll just bang through them. So it says, this question is about gases, okay? Gases, I'm crossing it out here. I'll get used to this pen in a minute. When sodium is added to water, hydrogen gas is produced. Brilliant. Now, we'll remember that for later, because it'll come up later. What observation shows that a gas has been produced? Now, have you learned your gas tests? Essentially, we should see here effervescence of hydrogen gas. Okay, that shows a gas has been produced. We are seeing bubbles. Effervescence is a fancy word for bubbles. Okay, the name given to Group 7 in the periodic table. These are the halogens. That's what they're called. Okay, and the group given to Group 0, the name to Group 0, these are the noble gases. Job done. Right, now, next we've got a bit of balancing here. So, complete the balancing equation for the reaction. Now, the state symbols for each substance. Now, 3 marks, okay. Now, what that means is you're going to get at least one of these for the state symbols. Okay, and they're fairly straightforward. So, sodium, first of all, let's do these. Sodium is a metal, so it's going to be a solid. I'll do them nice and big. Water, liquid, obviously, it can't be aqueous, it's water. Sodium hydroxide, now it says, forms sodium hydroxide in solution. It's telling you it's aqueous. And hydrogen, you should know that's a gas. Please note, the only one in there that isn't basically common stuff, it tells you what it is, okay? You should know a metal is going to be solid. You should know water's a liquid. You should know hydrogen's a gas. The only one which is a bit iffy is sodium hydroxide there, and they tell you it's aqueous in the question. Okay, we've now got to balance this. Now, there are only 2 requirements for numbers here. The H's H2 over here is fine. Okay, so we've got to balance. Now, I would start here with the H's. Now, I'm going to write this down like I do. Now, over here so far we have 3, and over here we have 2 times 2, which is 4. Okay, so we've got 2 H2O's. Okay, so essentially we've got that going on, which means we've got 4 H's, right? Now, we've got to get 4 over this side. Now, we can't fiddle with this one. This one doesn't need a number. Okay, we can mess with this one. That's only 1. So what we need to do is if we have 2 NaOH's, we now have 2 of those, NaOH, and then just a H2. We now have 4 H's. 1, 2, 3, 4. Okay. Now, how many NAs do we now have? We have 1, we have 2. Okay, so that means we're just going to have 2 of them. Job done. Easy peasy. So, there we are. Balancing that equation. Straightforward enough stuff. Just keep practicing those. Now, the next 2 questions says lithium, sodium, potassium are reactive metals in Group 1 of the periodic table. In an experiment, equal sized pieces of lithium, sodium, and potassium were added to separate samples of water. Okay, now you'll remember seeing this. You'll remember seeing a flame for potassium. Okay, and this is because it's the most reactive. Okay, it's so reactive it causes the gas to burn. That's why you see a flame. Teacher demonstrated this experiment. Describe in detail how the teacher would demonstrate this experiment safely, showing the results in the order of reactivity of the metals. Okay, so hang on, I've accidentally moved the page and trying to scroll it. So how would I do it? First of all, okay, I would get a, you've got to say how I would do it. Okay, how would I do it? I'd get a trough of water. Okay, lots of water. Obviously an equal volume though for each one. Equal volume for each one. Okay, so plenty of it. You know, you've seen the trough we use. We're gonna fill that up more than halfway. Okay, you're gonna use tongs to remove metal from the oil, stored in oil, stop it reacting with the air. You're gonna dry the oil. So I don't like dry, let's just, I'll be removed. Drying suggests it's wet. It's not, it's oil. So the oil is removed, okay. We're then going to cut a small piece and then behind a safety screen we're going to add to water. Okay. Now, this bit's important, okay? Safety. Now, we've said a small piece, that's safety, and we've said about a safety screen. That's safety, okay? So we've talked about safety here. You've said how I would do it, okay? You've seen us do this. You've seen us do it many times. I did it a bit. You've seen the flames. You've seen all the whiz bangs and all that, okay? This is how you would do it. Now, it also says, how would the results give the order of reactivity, okay? So the most vigorous bubbling, that would be with potassium, okay? And you could also say the least vigorous bubbling would be with lithium. Okay, so basically you are comparing them there. You're saying this one's the most reactive, this one's the least reactive. Okay, you've got all the results up here telling you about it. Okay, then you just go, I'm going to say order of reactivity. So I would just very quickly, I would say most, we'd say potassium, least lithium, and then just sodium in the middle, showing that it's in the middle. Okay, there we go. That's a good answer for that. Next, it says lithium, sodium, and potassium and reactive metals moved by the periodic table. In an experiment, equal size around separate samples of water. This looks like exactly the same as the question we just did. Flame is only produced with potassium because potassium is the most reactive. I think that is exactly the same. Yeah, exactly the same as the question we just did. Fantastic. Now, next we have more questions. Question 6 says, Group 1 metals react with elements of Group 7 to form salts. You'll find these elements on the periodic table. Just to remind us, we've got Li, K, and Rb. And then on the other hand, we got F, Cl, Br, and I. Okay, you've got those. Those are the order they come in. Okay. Now, explain in terms of their electronic configuration, the relative reactivity of these elements. Which one would be the most violent? Okay. So, we've got to talk first of all about, in terms of their electronic configurations, okay, so we're going to say the group 1 electron in outer shell loses 1 electron to form positive ion. I'm going to run out of space here, I think. Okay. As you go down the group, the electron, so we'll say rubidium electron, easier to lose, as it's further from nucleus. Okay, so that's basically explaining the reactivity of the group 1s. So basically, you've then got up here, we've got the least and the most for group 1. Hang on, I've put a line between them, so I should have differentiated that if I'm going to do this, because obviously it's the other way around for the group 7s. So we've basically talked about the order of reactivity for those group 1 metals. Okay, now all you then have to do is say you're going to write this out, obviously, in your actual exam. You're going to write this out. The opposite applies for group 7. Okay, that basically means there's 7 in the outer shell. They gain 1 electron to form a negative ion. Okay, we're then going to say that the fluorine, the outer shell is closer to the nucleus. It's easier to gain 1. Okay, so this is the most reactive for group 7. And this is the least reactive. Okay, so essentially you're just going to say the opposite. I mean, you need to write all that out. Okay, I'm going to run out of room here if I try and write it out. Okay, I should have written a bit smaller. You're just going to say all the opposite of what you've just said about group 1. Okay, and that will get you the 4 of the 6 marks. Okay, you then have to say which ones you think will be the most violent. Okay, now for me, I mean, if we can look, okay, we can see we've got potassium and fluorine reacting. Okay, now potassium is in the middle, but fluorine is right at the top. Okay, so I would say that potassium and fluorine most violent. That's the word it tells us to use. Violent. These two are the most violent due to potassium being in the middle of group 1. Okay, and so hang on, so very reactive. It's not the most reactive one we're given, but it's very reactive. And fluorine being at the top of group 7, that makes it the most reactive in group 7. Okay, right, next. This question is about elements in group 1 of the periodic table. The elements in group 1 react very vigorously with water. The student suggests this method to see what happens when sodium reacts with water. Put on safety glasses and a lab coat, cut a 2 by 2 by 2 cube of sodium, put a few drops of water in the container shown in figure 4 and add the sodium to the water in the container and observe the reaction. Now, give the name of this container here. Now, this is a boiling tube or a test tube. Okay. Now, the teacher says the method is not safe because the reaction is too vigorous. Give a change that can be made to step 2. Now, 2 centimeters by 2 centimeters by 2 centimeters. That is a huge piece of sodium. Okay, that is a massive piece of sodium. That's more sodium than even I would put in. Okay, and I'd love to put a big piece of sodium in. It goes bang, everyone's excited. That is huge. Okay, so you basically, what you would do, you would cut smaller piece of Na. Okay, Now, why would you do that? Okay, so it says explain changes that would make the method safer. Why would you do that? Okay, that would make a slower reaction. That's why you would do that. That would make it safer. Okay, I know we don't like a slow reaction. We want to see it explode. We want to see fire. We want to see fun things. But it would be safer with a smaller piece because that's a slower reaction. Remember, this is a hypothetical thing we're talking about in an exam. It doesn't matter. Use a tiny piece, whatever. You're not going to have to look at it. Okay, that would make it safer though. Now, for step 3, put a few drops of water. Now, you may or may not remember me doing this, but I put a considerable amount of water in a container. Okay, so I wouldn't use a boiling tube because there's not enough water in there. Okay, I would use a trough with a large volume of water. That's what I would do. With a large volume of water. I'd use a trough with a large volume of water. Okay, more water means more heat absorbed. Okay, that's what it means. Figure 8, question 8 rather. It says this question is about elements in group 1 of the periodic table. Figure 3 shows the symbols of the first 3 elements in group 1 and their melting points. Wow, okay. Let's have a quick annotation of this while we're doing this. Look, these are, as you go down, they are getting lower. Brilliant. I've just looked at that. I've just identified that. Okay. Ooh, see it down there. Now, give the symbol of another element in group 1. Now, this is easy peasy. You just look at your periodic table. What's below potassium? It's rubidium. There you go. What's the atomic number of lithium? Again, look at your periodic table and write 3. Remember, lithium, 7,3. That one there is the atomic number. This is the mass number. It's not asking you for that. It's asking you for the atomic number. Okay. Describe the trend in melting points of the elements in figure 3. Well, I mean, it's enough to say as you go down the group, like the arrow I've drawn there, the melting, get this right, not boiling, melting point decreases. Okay, if you say boiling point there, you will lose the mark. Okay, because it's not asking about the boiling point, it's asking about the melting point. It even tells you it's the melting point. Observe, use the words they give you. Right, next. It says lithium, sodium, potassium are reactive metals in group 1 of the periodic table. Explain in terms of electronic configurations the increase in reactivity from lithium to sodium to potassium. Okay, we've already kind of answered this. Okay, now we're going to say as you, I'll try and do this smaller, as you go down group 1, remember we've got lithium, which is 2.1, sodium, which is 2.81, and potassium, which is 2.8.8.1. As you go down group 1, okay, the atoms get larger. They do, because there are more shells. More occupied electron shells. So they get larger. Okay, that means slash the outer shell electron. Where is it? It's further from the nucleus. That's where it is. Okay, it's further from the nucleus. That means it's easier to lose. Okay, outer shell electron, easier to lose. Again, try and avoid saying it and stuff. Just use the terms. Okay, the outer shell electron is easier to lose. Okay, that's why they get more reactive if you go down group 1. That is that. Fantastic. Right. Okay, here we go. I think this is the last row of pages. It is. So, answer the question with a cross in the box you think is correct. That's for later. Rubidium reacts with water to form rubidium hydroxide and hydrogen. You know all things in Group 1 react the same. Predict what you would see when a small piece of rubidium is placed in a large volume of water. Okay, now, a lot of this is just stuff you can say happened to the other metals, because they all react in the same way. Okay, so for example, I would see bubbles. It's going to make bubbles of hydrogen gas. I'm going to see bubbles. Okay, the solid is not present. Okay, so the metal disappears because it reacts and forms rubidium hydroxide. So the metal has disappeared. You could also say the metal moves around because it'll move around on the surface of the water. Okay. Now, you'll remember if I put enough potassium in, it exploded. It went pop. Okay. So we could basically say, okay, it's going to react violently. Hang on, violently / explode. That's what's going to happen to it. Okay. Now, why is rubidium more reactive than potassium? Okay, let's have a look. Why is it more reactive? Metallic bonds in rubidium are weaker than those in potassium. It's nothing to do with that, is it? It's about losing an electron. Nothing to do with metallic bonds. Rubidium is a softer metal than potassium. Again, doesn't really, are soft things more reactive? My arm is pretty soft. Is it reactive? No. So, yeah, the outer electron of a rubidium atom is further from the nucleus than potassium's. That sounds like a credible answer. Rubidium has a more exothermic reaction with water than potassium does. That's probably going to be true, but it doesn't explain why it's more reactive. Okay, so the answer is C. Now, its next says, okay, maths. See, maths comes up everywhere. 8.5 grams of rubidium are reacted completely with water. The reaction makes a solution of rubidium hydroxide. Calculate the volume of the solution is 2.5 decimeters cubed. Calculate the concentration of the rubidium hydroxide solution, okay, in grams per decimeter cubed. Okay, so all we've got to do with this, okay, first of all, we've got to work out our concentration here. Okay, so our concentration is going to basically revolve around how much of this, but remember, we're looking at rubidium hydroxide here. This is the tricky bit, okay? It tells you how much rubidium is reacted, okay? You've got to work out how much rubidium hydroxide is formed, okay? So let's do that first. RbOH. So our mass of this is 8.5. Our MR of rubidium is 85. That means we've got 0.1 moles. Okay. If we look up here, it's 2 to 2, 2 to 2, 1 to 1, 0.1 to 0.1, meaning you get 0.1 moles of this. Okay. Now, the MR of this tells you is 102, which means we are essentially going to make 10.2 grams, okay? 10.2 grams of rubidium hydroxide, okay? Now, C is M over V, concentration is mass over volume, so C is just going to be 10.2 divided by 2.5, okay? And that's going to give us the answer, which we're going to write on the line here, 4.08 grams per decimeter cubed. Brilliant. Next, it says, answer the question with the cross in the box you think is correct. What are Group 1 elements called? They're called alkali metals. Easy peasy. Right, some elements in the periodic table are metals. Lithium, potassium, and rubidium are alkali metals. Describe what you would see when a small piece of rubidium is dropped onto water. Sounds very similar to a question we've just answered. Okay. Now, again, you could use descriptions of what you saw when other alkali metals are dropped onto water. Okay. So bubbles and the metal disappears. Now, most of you in the mock would have got that one, okay? The second one, not so much, okay? So you're getting 1 out of 2 on that, most of you. It's a very straightforward second mark. Just keep it in your brain, okay? Right, this next one is asking us to explain, in terms of electron configurations, why lithium is less reactive, okay? Now, we've already done this the other way around, explaining why lower down things are more reactive, okay? But it's asking us to say it about lithium this time, okay? So we're going to say, in lithium, the outer shell electron is closer to nucleus. Okay, therefore it's more attracted. So again, electron, I'm always telling you not to say it. The electron is more attracted to nucleus, therefore outer shell electron is harder to lose. There you go, 3 marks. Now, final question. It says, this question is about potassium and zinc. I mean, this bit's only about potassium. Which of the following temperatures is most likely to be the melting point of potassium? Now, you've seen potassium, okay? It's a solid at room temperature, which means it's not A and it's not B, okay? Because if it was A or B, it wouldn't be a solid. It would have been, room temperature being 23, B would be a liquid and A would be a gas, okay? It would have melted and evaporated by then, okay? Now, you'll probably remember it melts quite readily and forms a ball, and sodium does this as well, okay? Because its melting point for a metal is quite low, okay? So the answer therefore, is 63. Okay, guys. Now, I was going to crack on and do the alkali and do the group 7. As you can see, I've prepped this page with a load of group 7 questions as well, okay? I was going to crack on and do those. Equally, I thought, maybe if I do those at some future point, we can then have 2 shorter videos instead of 1 longer one, which might be more useful for you, okay? So I'm going to stop this here. I'll stick this on YouTube, okay? So you can see it, you can watch it anytime. I hope it's been helpful. This is Group 1 metals. Now, I got these questions, okay? I got these questions off Physics and Maths Tutor, okay? So they're just from here. So all you've got to do is get yourself in there, get those downloaded, you can work through them, you can listen to me doing them, okay, and all will be well, okay? So thank you very much for watching. I've seen like a few viewers popping in. I'll give you more notice next time so more of you can possibly watch. Thank you very much. I will do another one of these very soon.